So let's move on to question number 163. It says that which one of the following elements is unable to form MF6 3 minus ion. So the first thing is you calculate the oxidation state of MF6 3 minus. So for MF6 3 minus, you basically have, suppose oxidation state of M is X plus 6 into oxidation state of F is minus 1 is equal to minus 3, which implies my X is going to be in plus 3 oxidation state. So whatever metal that I have, I'm going to have it in plus 3 oxidation state. Now, in order to have further, so once it has absolutely in plus 3 oxidation state, for 6-fluorine to be a ligand, there has to be some empty orbitals present in it. Mind you, in boron, once it comes in plus 3 oxidation state, it has absolutely no vacant orbitals present on it, where my fluorine ligands can donate its electron and form a coordinate bond. And it is for this reason my boron is not going to be able to form MF6 3 minus type of ion, because it does not have any vacant orbitals once it achieves plus 3 oxidation state. On the other hand, you know that in that group down the elements from aluminium, gallium, indium, everybody has vacant d orbitals once they achieve the plus 3 oxidation state. But since my boron is in my second period itself, there are no d orbitals at all, and hence my fluorine is unable to act as a ligand for boron, and hence MF6 3 minus ion cannot be formed for boron. But for aluminium, gallium and indium, they have vacant 3 orbitals present on them even after the metal achieves the plus 3 oxidation state, and it is for this reason they are able to form MF6 3 minus. Hence for question 163, option is B. Option is first and answer is boron.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.